Welcome to physics class. Question 6. A copper wire has diameter 0.5 mm and resistivity of 1.6 into 10 raised to power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? Diameter of the wire D 0.5 millimeter. We have to convert it into meter. 0.5 into 10 raised to power minus 3 meter, cos meters are the SI units of length. Resistivity rho given in the question 1.6 into 10 raised to power minus 8 ohm meter. Resistance R 10 ohm. Area of cross section A equal to pi d square upon 4. As we know, A equal to pi r square, and which may be equal to, while diameter is given, so we have to change this. Pi r is d by 2 square, and in turn it will become pi d square 2 to the 4. That's why we have written it here. As we know, R is equal to rho L upon A. When we have to calculate the length, then the relation will become RA upon rho. At the place of A, we will write this. It will become R pi d square upon 4. Okay, and rho. Let us fill the values. L equal to R. R is 10 pi 3.14 d square. D is 0.5 into 10 raised to power minus 3 square upon 4 rho. 4 multiply value of rho, which is 1.6 into 10 raised to power minus 8. L is equal to, let us solve this first of all. 10 multiply 3.14 multiply, it will become 0.5 multiply 0.5 into 3 to the 6 minus 6 upon 4 into 1.6 into 10 to the power minus 8. We will write here 10 multiply, we will remove the points. It will become 314 into 5 multiply 5 upon 4 multiply 16. Now we will write their values of points. 1, 2, 3, 4 means 10 raised to power 4 here, and for this we will write here 10. Rest, this is 10 raised to power minus 6, and it will become 10 raised to power 8 plus value when it goes upward. Okay. First of all, we'll solve this. 10 multiply 314 into 5 5 the 25, 16 4 the 64. 10 raised to power minus 6, 10, 8, and this 10 means plus 9. This is 10 to power 1. In multiplication, it will add on in upon 10 raised to power 4. When we multiply 314 and 25, it will be 7850 upon 64. We'll move this 10 here, and from here we get 10 raised to power 3 and 10 to power 4. It will cancel out these values here. When we solve this, the answer will be 122.7. This is length, that's why unit must be meter. As we know, R equal to rho L upon A, which in turn becomes equal to rho L upon pi d square upon 4. We can write this likewise 4 rho L upon pi d square. From this we can write it here likewise R is inversely proportional to the d square. Means if diameter get doubled, resistance will become 1/4. As we know, according to question, R is 10 ohm. So its value will become 1 upon 4 into 10, which is 2.5 ohm. Question 7. The value of current flowing in a given resistor for the corresponding values of potential difference across resistor are given. Current in ampere and potential difference in volt. All the values are given here. We have to plot a graph between V and I and calculate the resistance of that resistor. According to question, there are 5 sets of value for the current and potential difference. We have to plot the graph. For that, along x-axis we have taken potential difference in volts. Scale used 1 division equal to 1 volt, 1, 2, 3, 4 volts, and so on. Along y-axis we have taken current in amperes, and scale used y-axis 1 division 0.5 ampere, 0.5, 1, 1.5, and so on. According to the given 5 set of values, we can plot the graph likewise, and we have to match the line. Using Ohm law, V equal to IR. We have to calculate R. R equal to V upon I. To calculate the resistance of the resistor, we take any one point, means any one set of the values. We will use from the given values. V means potential difference 13.2 volt, and for that set value of current is 4 ampere. Let us fill the value. V 13.2 I 4. Approx answer will be 3.3 resistance ohm. We can use any other set of values for this. Okay. Question 8. When a 12 volt battery is connected across an unknown resistor, there is a current of 0.5 milliampere in the circuit. Find the value of the resistance of the resistor. Potential difference is 12 volt and current given is 2.5 milliampere. 1 milliampere equal to 1 upon 1000 ampere means 10 raised to the minus 3 ampere. So we have to convert current into SI unit ampere. According to question, potential difference is 12 volt and current is 2.5 milliampere. As we know, SI units of current is ampere. We have to convert milliampere into ampere. 2.5 into 10 raised to power minus 3 ampere. As we know from the Ohm's law, V equal to IR. So we can calculate R. resistance. R is equal to V upon I. Let us fill the values. V is 12, I is 2.5 into 10 raised to power minus 3. First of all, we will remove this point. Then it will become when we solve this, answer will be 4800, and this is resistance. That's why its units will be ohm. We can write this likewise 4.8 kilo ohm. Question 9. A battery of 9 volt is connected in series with resistors of 0.2 ohm, 0.3 ohm, 0.4 ohm and 0.5 ohm and 12 ohm respectively. How much current would flow through the 12 ohm resistor? 5 resistors are given in the questions. Their values are given, and we have to calculate current across last resistor, that is 12 ohm resistor. Given terms: R1 0.2 ohm, R2 0.3 ohm, R3 0.4 ohm, R4 0.5 ohm, R5 12 ohm. Potential difference V, that is 12 volt. In the question, it is given that all the resistors are connected in series combination. So, equivalent resistance in the series combination can be calculated as Rs equal to R1 plus R2 plus R3 plus R4 plus R5. Let us fill the values. 0.2, 0.3 plus 0.4 plus 0.5 plus 12. Rs will be, by adding them, 13.4. We have to calculate current here from Ohm's law. We know that V equal to IR. So I can be calculated as V upon R. V is 12 volt and R we have calculated 13.4. It will become 120 upon 134. When we solve this, answer will be 0.67. This is current, that's why unit must be ampere. As we know that in the series combination, same current passes through all the resistors. That's why 0.67 ampere current also passes through 12 ohm resistor. 10th question. How many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line? Given terms: current 5 ampere, potential difference 220 volt, and resistance of one resistor 176, and we have to calculate N, means number of resistance. Current I, 5 ampere, potential difference V, 220 volts, resistance of each resistor that is given in the question, which is 176 ohm. From Ohm's law, we know that V is equal to IR. First of all, we will calculate R, resistance of the combination. R is equal to V upon I, 220 upon 5, and it will be 44 ohm. Now, if n resistors, each of resistance 176 ohm, are connected in parallel to give equivalent resistance of 44 ohm, that is Rp, then Rp, R upon N, that is fill the value, R, P, which is 44. R, resistance of each resistor, N we have to calculate. Then N will be 176 upon 44. Answer will be 4. So number of resistors will be 4 here. Thanks for watching.